Hi, folks. Welcome to this session on business intelligence. My name is Arvind, and I'm going to be talking you through this overview on BI. You could also call it data analytics, and hope you guys would find it interesting and kind of a precursor to many more sessions to come on this subject. This session is going to help you more in terms of giving an overview of multiple themes or topics around this. So what I want to cover today is BI is all about data. Yeah, it's understanding the data. It's understanding how data can drive better decision making. So we'll talk a little bit about that and what role data has to play in giving you the kind of analytics that can draw or drive value to the business. We'll talk about what has been the evolution of BI. There has been BI has been in vogue for many decades right now, and it has evolved from what it used to be, more of looking at hindsight, to what today is a big data driven prescriptive models. So we'll look at that. We'll look at some reference architecture, which could help you understand what are the tools, technology, the different stages of building analytics platform. Yeah. Finally, I'll come to what is your role. What is it that you could look forward to in terms of different rules that are in vogue. We'll talk about data engineering. I'll talk about data scientists, and we'll understand what does it mean for you to play roles like that. That essentially also would give you insights into what the industry typically looks for. And hopefully, this is going to be just a beginning. So hopefully it will give you some insights which will become a lot more clearer as we go in this journey. Yeah, I will open it for any questions, question and answers towards the end. So feel free then to ask me anything around this topic, and I'll be happy to answer that. Okay, so let's start. Okay, so what is business intelligence? BI basically, if you look at a very standard definition, is the process of discovering valuable trends or patterns in data. Yeah. Why is it so important? The key aspect here is when you look at data, and data in the past has been quite standard, quite structured, and it's helped you always understand how your business is doing. Yeah, typically in the form of dashboards, in the form of some key performance indicators, but more importantly, as time has with time, we have got more and more tools, more and more data, importantly, because of which you get a much better perspective of your business goals, your aims, what are objectives that you've set out, how to arrive at a good decision to ensure that you're able to meet your business objectives is what BI drives. Yeah. So if you're able to build a system which helps discover those patterns and trends in the data, which can drive good decision making, accurate decision making, I think you have then achieved a true business intelligence system. Yeah. So to understand what is the value of data, let's understand it on two axes. So on one side, if you look at it, the y-axis is the value of data to decision making. On the x-axis, you see time. Yeah. So what's the relationship between the two? If you look at it historically, and even now in many places, in many situations, many scenarios, you would see that looking at data which is longer in terms of time horizon, meaning months and days and weeks, and based on that, making certain decisions about what you want to do. Yeah. So typically, for example, you might look at the sales performance over the last 12 months of a particular product line or the last 1 quarter. And based on that, you might decide that you want to either discontinue the product because it's not profitable and it doesn't seem to be, it's just going downhill. Or you could understand that there's a particular cyclical nature to the sales of that product. And while it sells in a particular time of the month, maybe that's because there are certain holidays or there are some festivals, and it doesn't sell over the rest of the months. So that could give you some insight of how you want to introduce that product and when do you want to introduce. Movies, for example, sometimes are just launched at a particular point of time. Not the best use of data, you don't need that. But in products, definitely, you would decide that a particular product has got a seasonality attached to it, or a particular product has got a variation in age groups of people who are consuming it, or the different regions which consume that. So based on all of that, it requires a cyclical data, it requires a longer time period. That gives you some value related to that, right? On the other extreme, you would find, you go to Amazon right now or a Flipkart and you try to consume, you buy something. The moment you put something in the shopping cart, you suddenly get some recommendations. If you bought some book, it suddenly tells you based on their understanding of your past purchases, your age group, and various other data that they might have collected over a period of time. They will actually recommend you, saying that people similar to you have actually brought these books as well. Would you be interested? Yeah, that's the way they prompt you in real life, in real time. And that's basically what gives a value of data-based analytics in real time. So those are the two spectrums. It's not that one is more valuable than the other, but it's to look at it this way, saying if you are looking at only past data, then the value you derive is only limited. You could launch a product differently, or you could take some call about a particular salesman performance. Could be different things, but it's only so much limited. Nothing better to just show you in this way. So you have, for example, different sales stages. You have got sales manager performance. You are trying to look at the sales performance over a period of time, and that helps you decide whether should you change your sales strategy, should you change your sales mix or the product mix, or should you change your salespeople themselves. Yeah. Now this is all based on that kind of longer insight, and the changes, the decisions are also more longer term. Value-wise still could be high, but transaction-wise not necessarily the most high. Whereas if you look at this example is what I was talking to you about, and recommendations like this, when looked at a scale where they are impacting millions of customers who are transacting on a hourly basis, on a daily basis, on a minute basis, and coming out with recommendations has got a huge impact. So if you really look at these two spectrums, you see the role of what we would call as traditional BI would be, and where a modern BI would be. So when you look at traditional BI, it's more hindsight driven. You're looking at the past, you're understanding how your business did, and based on data which is not the latest. It probably is loaded on a monthly basis. You then identify what has gone wrong in the past. Based on that, you then try to arrive at certain decisions which will help you move forward. Yeah, and that typically would take the form of an output from a BI, which would be in the form of pre-built reports, would be certain ad hoc querying as you try to understand from predefined reports. Okay, something like this is wrong here, or something needs to be seen a little differently, and then you do some ad hoc query to actually identify what's the problem. So it's still problem understanding, it's still that kind of analysis, and then you take some manual decisions. Cut to the modern world where you have the data is so humongous, it's so much that you really can't employ the same tactics. And the tools that are there today let you do a lot more advanced analytics. And these advanced analytics take the form of a much more prescriptive analytics. So you, instead of you trying to manually identify scenarios where you could change prices, for example, for a holiday package. Now, if you're selling millions of airline and seats and hotels, hotel rooms, it's going to be very difficult for you to keep a track of what has been the sales of each of my room types in every hotel. If I'm a booking.com, for example, and I sell millions of hotels, how should I add value to a customer who's searching for a hotel, provide him or her the best price, and in case the business that is actually hosting those rooms on my network, if the prices are too low, can I help them by increase their profitability by bumping up the prices when the demand is quite high? So keeping the balance of both the business profitability as well as the customer experience, predicting demand and being able to actually prescribe what the decision should be is the kind of analytics that we're talking about. So what is it all based on right now? I think the whole of the entire notion of new form of business intelligence is all based on the fact that there is big data. Yeah. And when we talk about big data, is it just the volume of data? I mean, we all know there is huge amount of data right now. And this huge amount of data is no longer running into gigabytes. We're talking about petabytes. We're talking more than that. I mean, you can just go over and over, multiply that depending on the industry sector or the use case that you're talking about. But importantly, it's not just about the size of the data. It's also about the variety of the data. When I talk about variety, you look at data which is a lot more structured on one end, and this used to be the way a lot of the data in a traditional BI would be. It's still valid. When I talk about structured data, it could be your inventory, it could be your payroll, it could be payables, it could be the contracts, could be many things which are extremely structured. It's structured because the interactions are extremely structured with what you want to collect as data entry inputs and what you want to analyze. But then you see more and more forms of data which is extremely unstructured. And this, right from being clickstream data from different websites to GPS coordinates, you carry your mobile and every kind of data that is collected of your movements, the digital marketing, audio, video, social sentiment, you name it, right? From all your social media, what data you collect, everything is unstructured. So that variety of data coupled with the volume, and then you look at the velocity of how frequently you have to process this. It's no longer once in a month. It's no longer once in weeks. It's now real time. And that kind of velocity that you have in the data is because of uh, uh, the amount of data, and all of this basically lends itself to what we now call as the big data. Yeah. Now, if you can add a fourth V, there probably might be a fifth and a sixth one also, but veracity does become an important aspect. What I mean by veracity is the accuracy. When you are looking at this sheer size and variety and the velocity of the data, it is important that the results of any computation that we do does come out quite accurate. And if you couple it with the fact that we are now looking at prescriptive analytics, where the system is actually making a decision on your behalf, you are looking at potential disasters if you are not accurate in the output. And we'll come to it, when we look at all these modern technologies like machine learning, where you no longer are putting programming. You're not programming the output, yeah, not necessarily directly. So you're not writing all the if, then, for loops and trying to define what the logic should be. You're actually leaving it to the system to learn from the data, learn from the past experiences, and then put that into a model through which it will continue to learn and predict. Now, if that is the way going forward, how the system learns from the data and with what accuracy does it actually produce the output is extremely important. Yeah. So I think that's the new world which is rapidly changing the old traditional BI. So if you look at this old traditional BI, the slide depicts that simple form, simple at least in conceptualization, and you'll see a subsequent slide about the new way of looking at it, which has become a lot more complicated in that fashion. But if you look at it here, you're talking about typically some 4 layers. You always would look at the data sources, your OLTP systems, the transaction processing systems, ERP, CRM, any other lines of business-based systems who would provide you with structured data. Yeah. And this structured data then would go through a process of extraction from these, yeah, all structured data, but residing in multiple systems. You would need to get them together. You would need to transform them. You would then need to load them, yeah, and load it into a data warehouse, which would be structured way of looking at data from an end user's perspective, right? Remember, many of these systems, when we talk about an ERP system, we talk about a CRM system, when we talk about any reservation system or supply chain system, all of them have been fundamentally built to actually take care of transactions. Yeah, you do data entry, you store data, you update the data, you do all of that. You don't necessarily optimize them for reading, for querying, for drawing insights out of it, which is why it was always necessary to build a data warehouse. Yeah, a data warehouse would essentially structure the same data, but with an end user's perspective, which was more about decision making. If I, as an end user, would want to use that data to answer some of my questions, how would I want to structure my questions would drive the data model. We would normally call them as dimension modeling. There would be different. There are different types of that depending on the context, depending on the requirements. But fundamentally, it's all about storing that in different ways, which are extremely denormalized, and then they become the basis for drawing insights through dashboarding, through reporting, and so on. So those are the 4 layers if you see here. And that's how we always looked at things. Now, the relational data, as I said, has become different variety of data. We just went through it. If you look at the cost itself, the entire cost, instead of being a specialized on-premise hardware, has become extremely commoditized. It's no longer, uh, 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 you have AWS, you have Microsoft Azure, Google Cloud. All of this cloud essentially is telling you in very simple ways, saying, give me, don't spend time on trying to create the necessary environments, infrastructure to host all of your data. We will take care of it. You could do it before only because you knew that the data warehouse would only store so much of data and would answer only so much. The world today is quite different. Don't even know how much data you would require 2 months down the line. It's growing so exponentially and so fast. And you don't even know what all answers your users actually want to have, because it's all becoming more and more prescriptive. The data is so varied that they want to just play around with it. All of that essentially would mean you you put your effort in driving value out of the data, you leave it to us to create the necessary infrastructure, right? So it's become commodity. You don't have to spend time, you just let the cloud providers take care of it. Yeah. And the whole culture of looking at, how did we do, and trying to give a lot of analysis on that, which is more driven by operational reporting, is becoming more and more, saying, put the data. I don't know everything that I want to get out of it. I have some hypothesis. I will play with the data, drive some output out of it, which I'll then iterate before I get to what I'm looking for. And if you add all of the machine learning and various other things to it, it basically is a lot of experimentation-led action. Yeah. So that's where we are leading to. So I painted a picture of what modern BI on big data looks like. Is it all easy, great? Is it also simple? No, I don't. I think there are quite a few challenges to this. So let's see what are the key challenges. Now, at the center, you see determining how to get value. I've come across so many examples of our customers working on the premise that they need something like a data lake where they can push all kinds of data. They think that by putting all the data that is possible, users will actually drive a lot of insights, a lot of value. Very difficult. It's not as easy as it sounds. So getting that is a challenge. And we'll discuss what is it that we could do and what are the things that we can look at. Second, on the left, sorry, let me take the one on the right, and then we'll come to the last one, because that concerns you also. On the right is about integrating with existing IT investments. There's always a transition with so much of investments being done by customers on their IT infrastructure, on their business applications, everything. It's never an easy decision when you have to say that you just throw away your old systems, you throw away the old infrastructure and just use this. There is a lot going on with those old ones, and there's a gradual transition. You have to integrate with those systems before you transition them out and bring in the new. It takes time, effort, investments. Yeah, it's a big challenge. How do you continue to run the current systems, and how do you get the new one? The third one is becoming a big challenge as well. There is just not enough talent with all of these skills. And I'll come to it towards the end as to how does it actually impact you. But I think these three are the big challenges as we see the whole analytics, the whole data field evolving. Right. So when we look at deriving value from data, I'll give you some examples, but this is a slightly more wider set of use cases that people are beginning to look at across different industries. Why is it important? I think ultimately, and I'll come to, I'll show you something at the end where we will look at uh, how can you understand the domain a lot better. Um, any any work that you do in business intelligence is about uh, driving value to the business. Yeah, and when you got to do that, and if you have to do some work which adds value to the business in terms of helping them make better decisions, you need to understand that domain. I'm not saying you have to be an expert, but unless you understand that domain, it's difficult. Yeah. If I give you an example, if you are doing some yield management in travel, which essentially means that you're building a system which one is telling the business to increase or decrease price of a holiday based on whether something is selling well or not selling so well, or because the profitability is low, it is recommending that something be shut down, a hotel be closed down. Now, if you don't understand that business domain quite well, it will be very difficult for you to actually write the best algorithm to produce the right results. Yeah. In all of these things, while the horizontal understanding of the tools and technologies is a must, problem solving skill is even more important. And that will come only if you understand the problem, if you understand the domain to understand the problem. Yeah. So I will not go through each of these, but suffice it would be to say that today the problems that business intelligence is solving is no longer limited to addressing a problem that existed a month back, and then people just analyze something and come out with some decisions. It's all becoming more and more real time. Right. So we saw some simplified architecture of what a traditional BI system would look like. Now, this is how a reference architecture for a new typical data platform would look like. Uh, in the center, actually, there's a data lake. Yeah. Now, this whole thing about data lake is about ensuring that, unlike the previous data warehouses, where what goes into a data warehouse is very specific to what the users require, a data lake is a lot more open in terms of what all you can store. The fact that it is typically based on an infrastructure which is scalable infinitely on a cloud platform makes it little more, not little, I would say, makes it a lot more easy for organizations to scale up as data increases. So if I go from left to right, what you see is on the left, different data feeds. So data feeds, as we talked about, are, the talk about both the volume and the variety, right? So if you look at the variety here, the data feed could be streaming data. A Netflix could be streaming data, which is a lot more current compared to a structured data, which might reside in the form of flat files or enterprise systems coming from diverse sources. Now, you could also be extracting social data, which is extremely unstructured data, whether from Facebook or Instagram, and you might be making some real-time views of what is being done there in order to come out with some recommendations. All of this data is ingested. And when we say ingested, you basically build a data pipeline, you orchestrate the entire data. In the process of actually doing this entire exercise, you make sure that you are creating a catalog for this data. Metadata as a term, metadata as a concept is extremely important, more important in the current context of a data lake. Why is that? When you look at a data lake with the amount of diversity of data, you could, if you have a huge corporate, you're talking about data which has got, let's say, a travel company has got inventory data, has got bookings data, has got product data, all the holidays which are being sold. It has got contracts. It has got customer data. It has got customer feedback, customer complaints, you name it. Yeah. With all of this data coming into the data lake, uh, it's it's never going to be easy to find the data entities that you are looking for. It's important that you are able to create a catalog, a metadata, using which you are able to get people to search for the data that they're looking for, and then easily use that data in the context that they are looking for. So once you have created this entire ingestion pipelines, you are basically going to look at storing this data somewhere. That storage takes the form of, let's say in the AWS world, it could be S3 buckets. In some other world, it could be something different. But ultimately, it's a storage where there's a clean data, structured data with all the catalog and the metadata available. There is then a way to make sure that that data is used to further use it in the context of different use cases. Those use cases, if you go on to the right and to the top, could be different ones. Now, you could have a use case where when the users are searching for a product, they are given some recommendations based on the data which is currently there in the data lake. Now, if that is what they are looking for, that's one a use case. Another use case could be, I want to draw some inferences from the last 1 month of daily data on how, for example, the coronavirus is spreading right now. Yeah. So if I want to make some judgment about how effective the lockdown has been by looking at different aspects of the virus spread, then that could be something which I might shift to a data warehouse, which could be on, let's say, an Amazon Redshift, and then use some BI analytics layer on top of it to actually draw different inferences. I could use machine learning to learn from the results which have come out based on the raw data and make the entire system learn on top. All of this essentially is what would get put within this. At the bottom, if you look at it, security, monitoring, and data quality. These are the aspects which make it worthwhile and easy for us to use the data lake in a very secure environment. You need to have security because it's no longer one set of users, it's different set of users across the organization who are looking at it. You need to look at the logs. You need to look at how the data lake is being used in order to optimize it for further usage. You need to look at the data quality, because if the quality of the data is not good, garbage in is garbage out, right? So all of these essentially are different aspects which need to be monitored to make sure that the data lake is successfully giving the kind of results that you want. Yeah. I just have got 2 more slides on the same reference architecture, but that essentially is only how the same data lake, when you look at it from how it could be ported on AWS tech stack, would look like. And you look on the left, for ingesting data, you would use something like AWS Glue. You would use Kinesis if you want to do some real data streaming. You would use a DynamoDB for metadata store. And when you move into the center, the S3 buckets are where the data lake data would get stored. If you're using a Redshift data warehouse, that typically will be all for BI reporting, as I talked about. Yeah. And then if you come onto the right, you have got Elasticsearch as a search API-based use of that. And then if you go on the top, you could use Athena for querying, ad hoc querying. You could use Glacier for big data storage there, one-time storages using Snowball. You could also use Amazon SageMaker, but also some third-party tools like TensorFlow and PyTorch, which are all machine learning specific frameworks. So variety of tools. I mean, it's so many, and they continue to keep coming. That a slide definitely is not enough, but it's just a representation of what would be the key services that you might be using. And the same thing holds good for the Azure stack as well. Yeah. So I think my last couple of slides are just focused on giving you some insights of how you go about building a typical analytics system, what are the kind of roles. And if you look at this, a typical data warehouse or a typical BI or a typical big data system, they all follow similar processes. Yeah. And you would be typically familiar with them. What's more important also is that in the world of agile now, it's no longer about whether it fits this kind of BI applications or BI project delivery, product delivery. They all do quite well. And I think understanding how you can work in an agile way to deliver functionality in increments and then getting product owners, business owners to accept that, working in a team to deliver that, I think is quite important. Yeah. So what is your role in building a data platform? There are basically two key roles that typically you come across, or there are shades and varieties of it, and it could always depend on the context of the particular problem that you're trying to solve, or the kind of culture that the company is into. So you never really, I would say that I'm one or the other. It just depends on the context. So be flexible around this. Ultimately, if you look at the entire data science field, the entire BI field, it's a confluence of a domain knowledge which actually talks about what the business problem that you're trying to solve. It's about computer science, because that's where you are trying to use a plethora of tools and technologies, algorithms, your structured object programming, everything that goes into preparing the data and making some sense out of it. And then you have got maths and statistics, which is also equally important, and even more important in the current world, where it's more of AI machine learning based decision making, modeling, and everything that goes with it. Yeah. So while I've put down data engineers and data scientists, and data engineer typically being somebody who creates the necessary work, he does the necessary work, creates the infrastructure, creates the data pipelines, loads all the data in the necessary way, keeps it secure, optimizes the data at any point of time given performance requirements, makes sure that it's more and more automated, everything that goes into making the data more and more valuable, and works very closely then with the data scientist, who essentially has a responsibility for understanding the business, translating a business problem into a model, understanding what are the hypotheses that will actually work in that context, how can you solve that problem, converting that into different models, training the models with the data at hand, going through iterations, fine tune them, and at the end of it, propose that as a solution and something which can then solve the business and help them make better decisions. Right? So if you look at given all of this, if that's the role, you might fit into a data engineer, you might fit into a data scientist, or as I said, it could be a mix of both. What are the skills? What are the competencies that we need to develop? Yeah. Now there's a hard part of it. Very clearly, you will need to know a lot of these technologies that I just touched upon. You see some graph here. It's got a host of technologies which have been in use and listed for data engineering roles. Yeah. It doesn't necessarily mean that you should pick up the top two there and learn them, and then you have a greater chances of getting the job. It's just to give you a context of so many things that are being used. And in any given context, in the particular company, in the particular job, in the particular scenario that you're working on, you might have to use a variety of these. Yeah, but it's still the knowledge that you gain on its own, as long as you have the ability to learn new tools, new technologies as they come into the market. I think you would be still good, because there's never a static phase as far as these technologies are concerned. 2 years back, you would have seen hardly half of these in the market. Yeah, and probably 2 years hence, you might not see most of them. So I think you'll continue to learn, and as long as you have that learnability, I think you will do well. But I'm also, when the industry looks at people like you coming out of campus into the industry and starting to work, it's not just the thing on the left, it's more of the things on the right. Yeah. So we try to look for how well are you able to apply what you have learned. If you know Java, if you know Python, if you know SQL, if I give you a problem, can you solve that problem? Have you applied that in the context of any project, any assignment? What exactly was your approach? How did you go about writing that? I talked about domain knowledge. There is an absolute need and an expectation that in any project, in any work that you do, you will understand that business domain. Yeah, you will apply programming, you'll apply statistics, you will have problem-solving skills, which are required to come out with programming logic, to come out with different hypotheses to solve a particular problem. It's no longer somebody just telling you that this is the logic that I wanted to build, and you then coding that. Business analytics, data analytics, business intelligence, they are field right now which require a lot more problem solving skills. You need to have the attention to detail. It's not easy when you look at a humongous data and then you try to just analyze that. Yeah, your attention to detail would actually finally define how much of clarity is there on the data. What is it that needs to be done to make the data more amenable to decision making, cleaning the data, getting the right things out. Yeah. Last but not the least, you always need to look at teamwork. And when I say teamwork, when you get together in a team, there are always likelihoods of different people having different roles. But the team as a whole can achieve a lot more than each of the people within it. Yeah. So when you look at that team, and when you look at understanding the domain, when you look at the problem from a user's perspective, I think you have a greater chance of delivering a very successful outcome for the business. That's it from me, and I hope it was useful. So that's the end of this overview session. If there are any questions, I'm happy to answer them.